Hello, this is 1.1 again, functions. This is an overview part 2, and I just realized that part 1 was like 24-minute video, and should know that because it's in the lower left corner of that. I will try to make this one a lot shorter than the last one. But anyway, these are the next few items that we need to discuss, and we're going to be talking about the operation of functions, the difference quotient, and that's not a big deal for this course, but it will be more important for you guys in your calculus class that are coming up next. I just wanted to introduce what it is because you do see it quite often in this course. You just don't use it a whole lot. It's not a major player in this course. Implicit versus explicit form of functions. We'll talk about how a function can be written if it's an equation format. It can be written implicitly versus explicitly, and it's a very simple thing to discuss on that one as well. The first thing is operations on functions. The first 4 operations should be very familiar to you: adding, subtracting, multiplying, dividing. And the last one is the composition of functions, and this is going to come later. I'm not going to discuss it right here. I just wanted to put a bullet on that one as well, because that is an operation of function that you guys will be hitting in this course. We just don't talk about that one right now. We'll do that one a little later. But the first 4 that we are going to discuss in this section should be very familiar to you. Because when you add, subtract, multiply, and divide functions, it's the same thing as adding, subtracting, multiplying, dividing numbers. You add the terms, you subtract the terms, multiply the terms, or divide the terms. So it's one of those operations. Now, the thing about it is sometimes they're asking you for the domain. Now, in the last one I talked about, the notation for function is f of x, and I said the reason they use f of x a lot, the letter f, because the function begins with the letter f. It doesn't have to be f, though. It could be g of x, h of x. Remember I said I used a Pepsi machine? Pepsi, a $. The Pepsi is the name of the machine. So you can have a name of a function that's other than f. And so let me give you 2 functions. So f of x, let's say f of x is 2x minus 5. And g of x is equals to 3x plus 4. So when you add these 2 functions, this is a function and this one is a function. And you're like, I don't see ordered pairs. You say you mentioned ordered pairs. Well, if you want some ordered pairs, you have to give me some inputs. So if I said f of 2, seemed to be one of my favorite numbers last time, put 2 in, 2 times 2 is 4, and 4 minus 5 is negative 1. Remember I talked about that's how you evaluate a function. You put a number in and see what the output becomes. In this case, it's negative 1 because 2 is placed into the equation. 2 times 2 is 4, and 4 take away 5 is negative 1. So an ordered pair would be 2, negative 1. That's one of the ordered pairs of that relation / function. So in g of x, you can do the same thing here. G of 2 is equals to 3 times 2 is 6, and 6 plus 4 is 10. So 2 different functions. So it's like you could have 2 different pop machines. You can have a Pepsi machine and you can have a Coke machine. You have a candy machine. So you can have different kind of machines like that. So these are 2 different machines for functions. Okay. Now, but the thing about this is we can add, subtract, and multiply and divide these terms. So if you add functions, it's f plus g of x. That is the addition one. And on this one, all it is simply is just f of x plus g of x. So it's not multiplying this x through. It's not doing that. It's not like a distributive property at all. It's just saying, well, if I want to add the 2 functions together, it's no more than adding their components up. So f of x is 2x minus 5 plus g of x, 3x plus 4. Now sometimes you can't add apples to oranges because they're not like terms, but in this case they are apples to apples. So 2x plus 3x is 5x, and then negative 5 plus 4 is negative 1. So it's 5x minus 1. You're like, well, why would you really care about adding 2 functions up like this? Let me ask you a question. Well, what if you wanted to know what is f of g, f plus g of 2? All right? Well, if you want to know that, what you could do is put 2 into this machine and get the negative 1. And then put 2 into this machine and get the 10 that you got a while ago. And the answer is 9. But if you want to add the components up first, then use the 5x minus 1, so it's 5 times 2. Right there, so remember, f plus g of x is 5 times 2 minus 1, and that's 9. So it's the same number. But you're like, well, that's fine, but that's it's really not hard to do by putting this 2 into this one, 2 into this one, just add the numbers up. That's true. But if you had to do it a series of times, if you had to put not just 2 in, but you had to put 3 in, 4 in, 5 in, 6 in, 7 in, and 8 in, you're not going to want to put those numbers into 2 different functions and add those numbers up every time. You're going to want to get one set formula, 5x minus 1 in this case, and put those numbers in. It's a lot quicker. So that's why you learn how to add, subtract, multiply, and divide functions. It's because of it. You sometimes have to add and do those operations a series of times, not just once or twice. So, but that's what you're doing when you're adding functions, is you're just adding their components. Now, subtracting is very similar. When you subtract them, it's just f plus g, f minus g of x which is f of x minus g of x. So in this case, you subtract the components. So it's going to be 2x minus 5 minus g of x, which is 3x plus 4. And you just have to remember to distribute the negative. 2x take away 3x is negative 1x. And then here's the tricky one. Negative 5 take away the 4. It's plus 4. Sometimes that's a minus, which makes it a little bit more nastier because it would be two negatives, negative and negative. But in this case, it was a little bit nicer. Negative 5 minus a 4, which is negative 9. And I could do the same thing I showed you a while ago, is putting in 2 into both of these and then subtract the negative 1 minus 10, and that'd be a negative 11. Negative 1 minus 10 is a negative 11. But if I put 2 in here, look what happens. Negative 1 times 2 is negative 2, and negative 2 minus 9 is a negative 11. So it works the same way. So that's the subtraction. Right? So there's 2 more operations that are very similar to this one, and they work in pretty much the same way. So here you're adding the components and subtracting components. The next ones, you're going to multiply and divide the components. The divisions always usually cause students the most trouble in younger math, like elementary math, than anything else, the operation. But in this case, the division is actually the easiest one, because all you're doing is putting the things down in fractional format. I'll show you that in a second. But first, the multiplication. F times g of x is f of x times g of x. Okay? So it's just multiplying their components. So in this case, f times g of x is f times g, so it's going to be 2x minus 5 times 3x plus 4. So how do you multiply? Now sometimes the multiplication is done. You can't multiply the components. You just have to leave it in a product factored form, in other words. But sometimes you can FOIL, and this one you can. So let's FOIL this out. So 2x times 3x is 6x squared. This is O, the outer, is 8x minus 15x is a negative 7x. And then negative 5 times 4 is a minus 20. Now, check this out. What if I multiply put f of 2 times g of 2? Well, that's going to be negative 1 times 10, and that's negative 10. Guess what happens when I put 2 into this machine? Better get the same thing. Well, it's f times g of 2. So it's 6 times 2 squared, and that's 24. 7 times 2 is 14, minus 20. So you get 24 minus 14 is 10, and then 10 minus 20 is negative 10. And it's exactly what you would get if you multiply negative 1 times 10. But you're like, yeah, but that's a lot of work here. But again, you're not going to, if you're having to put more numbers than just 2 in, 3 in, 4 in, 5 in, 6 in, 7 in, you have to do that with every single problem. It doubles your work. Here, if I put 2 into this one, put 3 in, put 4 in, put 5 in. And if you have a nice calculator, you can actually just plug this thing in, just replace those numbers with that. So it does save you a little time later on. So it doesn't look like it's a great saving thing, but it does save some time in the long run when problems get longer. Now, and then the division. Now this one here is probably the most complicated one if you let it be in elementary, but not here. So if you have f divided by g of x, then it's alpha of x divided by g of x. Now look at this, and this is what I'm saying. This is why it's nice most of the time. Alpha of x is 2x minus 5, and g of x is 3x plus 4. The biggest mistake people make on this one is simplifying a fraction when you can't do it. Now this one, most people just say, oh, I can't do anything with it, but if the problem looked like this, I have a lot of people that would they would actually try to cancel this out because they see a 6 and they see a 3. And they think they can do something with that. So you cannot simplify this because this is not factored form. The only time you can reduce fractions if they're factors, okay, but not anytime else. So that one was actually 2x though, and but so unless you can factor this out, you're done right here. So now, one last thing I want to talk to you about operations of functions that are domain. When you're looking for the domain of their functions, and do the operations, the domains are pretty much the same way until you get to the division. This one is a little trouble because the domain of this function is all real numbers, because they'll take anything. 2x minus 5, there's nothing that can be excluded. This one, same deal. Okay, but this one, the quotient, is not all real numbers. You know why? Well, because if you have a fraction, you cannot divide by 0. So what makes it 0? Well, I don't know. Set 3x plus 4 equal to 0 and see what happens. Then x is negative 4/3. Now that's not the domain. The domain is actually everything except that, because that is what makes it 0 on the bottom. So even though the domain on the function is all real numbers, and the domain on this function is all real numbers, the quotient is all real numbers except what makes it 0, negative 4/3. So a lot of times when you're doing the division, you say this: alpha divided by g of x equals alpha of x over g of x, the rule, and then and I didn't say this a second ago, but g of x cannot be 0. So that's where you have to be careful. So, but otherwise, the domain of the addition, subtraction, and the multiplication, if you can't include a number in one of the original functions, you cannot include those numbers in the operation as well. So, but the division is a little bit more different. Okay, now the difference quotient. Now, most of the thing I'm just going to tell you about what the difference quotient is, I'm going to show you what it is. So, on the difference quotient, and you look at this thing and you're going to say, I've never seen that before. But in reality, you have. You just don't see the connection yet. But that is the difference quotient. And believe it or not, it has to do with slope, which is what we talked about in F3, the lines. Remember the lines? And that's actually the slope of the secant line. You know, how's that? Well, it's not. You're not using ordered pairs. Okay? You're using the same ordered pair twice. So if you have an x coordinate down here, this is x comma f of x. Now, you don't use another point. Remember, I used x, y before, but remember what y is. Y is f of x. So that's why I didn't put a y there. It's because y is f of x. Now, I'm not using x1 there, though. Okay, because I want to use that same point. What I'm going to do is I'm going to make there a space between these, and that space is going to be called h. That space is h. So this coordinate right here, you know, I don't know what that coordinate is then. Yeah, I do, because if this is x, you got to add h units this way, and so that is x plus h. That's the distance, that's that ordered pair because it's h units to the right of f of x. And then its y coordinate would be f of x plus h. Now find the slope of that red secant line using the slope formula. So it's the difference of the y's. So it's f of x plus h minus f of x over x plus h, this x coordinate, minus x. And then the x's cancel out, leaving you with f of x plus h minus f of x all over h. So what you're going to learn in calc, though, is that distance between these 2 points actually going to start getting closer together, which basically means these 2 points on the graph are going to converge. And so you're no longer finding the secant, the slope of a secant line, which a secant is when a graph hits when a line hits the graph 2 places. But when you let that h go to get very close to 0, those 2 points merge into the same point. And then you're not finding the slope of the secant line, you're finding the slope of the tangent line. Because remember what a tangent is, it hits the graph at one place. So that's what this is. It has to do with slopes, and we're going to be the first one to tell you what this is talking about, derivatives. So when you get in Calc 1 or 287, you'll start talking about derivatives, and you'll begin with something called the difference quotient, and you'll see that your teacher will teach you this idea again when you get in that course. And but that's what this is. It's the difference quotient. Now, in this course, the difference quotient is nothing more than something to play around with. They don't want you to come in there cold in the Calc 1 without seeing this at all. So when you see this in Calc 1, you're going to say, oh yeah, I seen that in pre-calc. Didn't do much with it, but I saw it. So, and they just don't want you going to come in there as cold without seeing that at all. So, but anyway, that's where it comes from. It's all it is slope. So you're in your mind, well, you need to start thinking of difference quotient, slope, difference quotient, slope. So just kind of put those two terms together in your brain and just kind of connect those together. But that's what it is. So if you write this down on your paper right now, this will be cool. This will be really nice for you to get this idea across when you take calculus. If you're not planning on taking calculus, you don't have to worry about the derivatives and stuff like that. So that's not going to be a big deal for you. So, but a lot of you guys who are in a pre-calc class will be end up going on to Calc 1, bigger and better things. So, all right. The next thing is the implicit versus the explicit form of functions. And I just basically told you what it is right there, and I'm not going to write anything else down here. I'm just going to leave it at this. But the implicit is the general equation. There's no f of x in it. So generally you have like the 2x plus 3y equals 9. You just have an equation. You don't see an f of x in there. So in order to solve, to get y, the output, you have to put the input in and do some solving for y to figure out what the output is. And you don't see an f of x. But once y is solved for you, or they just simply have f of x in the equation, they have f of x equals, this is what f of x equals, like the one I had a while ago, f of x equals 2x minus 5. That was an explicit function because f of x was solved. So all I had to do to figure out what the output was is to put a number in for the x and put 2 in and get that output. That's all I had to do. But if it was an implicit function, I would have to actually put the number 2 into the equation, do a little bit of manipulation, put everything to the other side of the equation, and solve for y. So simply put, implicit is basically when nothing is solved for. There is no variable solved for you. And the explicit is when y equals fill in the blank. So that's the difference between those two. Okay? It was a little shorter than the last one, but like I said, you can fast forward and stuff like that. So, but anyway, this is the overview part 2. We actually have 4 more videos. So the next video will cover in the textbook problems 15 through 28. And thank you for watching.